Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? And here we'll solve a definite integral involving the greatest integer function, right? So let us start, and here what we will do, we'll first apply the method of substitution to simplify this integral, right? And then we will apply two very important properties of greatest integer function to simplify this integral and to arrive at the value of this integral, right? So in fact, in this lecture we are going to see the significance of the properties of greatest integer function while simplifying or while getting the values of these type of integrals, right? So let us start. So now let us first take this integral as I, right? And here we'll first apply the method of substitution. So what we will do, let us first take x is equal to say minus y, right? So here we are changing the integral from the variable x to the variable y, right? So when we take x is equal to minus y, or we can also take some other variable like t or u, so here we'll prefer y, right? So we'll take x is equal to minus y. So dx, when we differentiate x with respect to y, we'll get dx over dy is equal to minus 1. So we'll get dx is equal to minus dy, right? Okay, now let us change the limits accordingly. See here x varies from minus 2 to x is equal to 2, right? So when x is the lower limit is minus 2, then the value of y can be calculated from this expression. So we have minus 2 is equal to minus y, so y is equal to 2, right? So this negative sign and this negative sign get cancelled, and we'll get y is equal to 2. And when we have x is equal to 2, which is the upper limit, so we'll get 2 is equal to minus y, so y is equal to minus 2, right? So when x goes from minus 2 to 2, y goes from 2 to minus 2, right? So now let us rewrite this integral in terms of y, right? So see what we will get. We'll get I, and here we'll get the lower limit as 2 and the upper limit as minus 2, right? And for x we have minus y, so we have minus y raised to 4, and here we have minus y plus half, and here we have for dx we have minus dy, right? Now we know an important property of definite integrals, that is related to the interchanging of limits. When we have a to b f of x dx, then we can write this integral by interchanging the limits as b to a, and we take a negative sign in front of the integral, right? So now we have a to b fx dx is equal to negative of b to a fx dx, right? So here we have this negative sign, right? So what we will do, we'll interchange the limits to neutralize this negative sign. So what we will have, we'll have minus 2 to 2. We'll interchange the limits to neutralize this negative sign, and minus y raised to 4 is simply y raised to 4, because 4 is an even number, right? And here we have minus y plus half, and here we have dy, right? So the first step is to get this integral, right? So now let us rewrite this integral as minus 2 to 2 y raised to 4, and see here we have minus y, right? And see here we have the number that is half, right? So half can be written as minus half plus 1, right? So here this is a very important step. because here we are going to write half as minus half plus 1, because here by writing half as minus half plus 1, we are going to apply the properties of definite greatest integer function, right? So what we have done here, we have written minus y plus half as minus y minus half plus 1, which is the same thing, right? Now let us apply the properties of greatest integer function to this term, right? See, we have now minus y minus half and plus 1, right? Now let us here assume minus y minus half this term as p, right? So we are just taking minus y minus half as p just for the sake of simplicity or for better understanding, right? So we'll take minus y minus half as p. So now this term becomes p plus 1, right? See, here we have got p plus 1. So p is this number and 1 is the integer, right? So here we'll now first apply the property of greatest integer function, which says that if we have a greatest integer of x plus n, where n is some integer, then we can write this as greatest integer of x plus n, right, where n belongs to the set of integers, right? So this is the first property which we are going to apply to this integral, right? So here see, if we apply this property to this term, then greatest integer of p plus 1 becomes greatest integer of p plus 1, and here 1 is the integer, so the value of n is here 1, right? So now the greatest integer of minus y minus half plus 1 can be written as greatest integer of p plus 1, right? So here we can write greatest integer of p plus 1, and p is here minus y minus half, and here we have plus 1, right? So now we have written this term or this term as the greatest integer of minus y minus half plus 1. Now let us apply the second important property of greatest integer function to this term, right? See, we know that the second property, that is greatest integer of say minus x plus greatest integer of x, is equal to minus 1 whenever x does not belong to the set of integers, right? So this is the second property. See, greatest integer of minus x plus greatest integer of x is equal to negative 1 whenever x does not belong to the set of integer, right? So when x belongs to the set of integers, then obviously the sum of these two terms is 0, right? Which is the well-known property of greatest integer function. So see, here we can write this term as greatest integer of negative of y plus half, and here we have plus 1, right? So now if we replace x by y plus half, right? So if we replace x by y plus half, then what we will get? See, we'll get a negative of y plus half plus greatest integer of y plus half, because here we are taking x as this term, right? So negative of y plus half greatest integer, then we'll add greatest integer of y plus half is equal to negative 1. Where x does not belong to z, it implies that this y plus half is obviously it is not an integer, right? So this is not an integer. So now if we take this term to this side, what we will get? We'll get greatest integer of minus y plus half, then we'll get minus 1 minus greatest integer of y plus half, right? So now this quantity, that is greatest integer of minus y plus half, minus half, and here we have plus 1. It can be written as c, for this term, that is greatest integer of negative of y plus half, we can write minus 1 minus greatest integer of y plus half. So here we'll write minus 1 minus greatest integer of y plus half, and here we have plus 1, right? And see, this negative 1 and this plus 1 get cancelled, and we are left with a negative of greatest integer of y plus half, right? So this is the most important step in this problem, right? So now see, the value of this term is equal to negative of greatest integer of y plus half. So now here we have the integral I. So I can be written as minus 2 to 2 and y raised to 4. And for this term, we can now write a negative of y, greatest integer of y plus half. And here we have dy, right? Now we can take this negative sign in front of the integral. So we have minus and minus 2 to 2 y raised to 4, and here we have the greatest integer of y plus half, and here we have dy, right? So now we have got this integral, and see, this integral is our original integral, because here the only difference is that this integral is in terms of x and this is in terms of y, right? So by making use of the dummy property of definite integrals, that is a to b, f of x dx is same as a to b f of t or f of y dy or f of t dt, right? So this is the dummy property of definite integrals. So here we can now simply replace the variable y by x. So we have negative of minus 2 to 2 x raised to 4, and this is x plus half, and this is dx, right? So this integral is our original integral I. So we have I is equal to negative of I, right? So now we have I plus I is equal to 0, 2I is equal to 0, so I is equal to 0, right?